Hello, I am Greg Livingstone with Fluid Tech, and thank you so much for making it to our next session here. If you deal at all with monitoring, maintaining, or in any way with turbo machinery, you have stumbled into the right place. This is a talk for you. I am very happy to introduce Gakuo Ndonga. He is with SKF, and he's going to be talking about bearings and lubrication, understanding the selection process, and then we'll have time for a few questions at the end. So, Gakuo, take it away.
Thank you for attending my presentation on bearings and lubrication as part of the Lubrication and Reliability Virtual Summit. And part of what I want to do is get you some insight for those who don't deal with bearings and lubrication selection often, is understanding what goes into that process. But before we get started, I'd like to tell you a little bit about myself. And my name is Gakuo Ndonga. I'm working as a application engineering expert, but I've also spent some time as a sales engineer and actually spent time as a maintenance mechanic early in my career. So I've seen different sides of the business. Now, my background, I was actually born in Nairobi, Kenya, which is a country on the east side of Africa, but I spent most of my time in the United States in North Jersey, which is not too far from where I got my bachelor's in mechanical engineering at a small university called Rowan. But now my interests really fall in line with the sport of soccer, or some people know it as football. So you can either catch me playing or watching on a regular basis. I also like to spend some time volunteering for local charities. And in terms of something new, I've actually picked up travel. That's me on the left in family property in Nairobi, Kenya, and on the right, scaling a large mountain, which is why I'm holding on to the rail in island of Kauai, which is part of Hawaii. So that's a little bit about me, but how about a little bit of who SKF and what I do on a regular basis? Now, have you ever thought of what keeps your world rotating? How is rotation affecting your world? Many of us drive cars. I'm sure even in your office or home, you probably have some form of a fan. That is what we're tasked with doing at SKF, keeping the world rotating. If many of you are not familiar with SKF, it's actually headquartered where it was founded in 1916 in Gothenburg, Sweden. And SKF has over 42,602 employees operating in over 130 countries with 87 manufacturing locations around the world. Now, many of you know SKF for bearings and bearing units, but SKF also does seals, industrial shaft seals, lubrication, primarily greases, condition monitoring, and services. So now that you know a little bit about my world and SKF's world, let's go ahead and talk about the selection process for rolling element bearings. Now, if you've ever gone through this exercise, you'll realize there's so many different designs. On screen, you have over 80 or more different bearing designs, but with all these choices comes many questions. So what is the right design? What is the right size? How is that design going to perform? When is it going to fail? How can I prevent the failure? And then how much will it cost? These are all questions that come up and it can be difficult navigating. And so what SKF has done is simplify this process to 9 key steps, which I'll walk you through, but they don't always have to go in sequence, okay? So let's start by talking about size. So what are the critical dimensions? Many times when you're selecting a bearing, you have a size restriction, some boundary footprint to work in, okay? So a lot of times the critical design dimensions are, you have a shaft or a sleeve where the bearing is going to sit. That tends to be fixed or with a certain range. Similarly, on the housing side, you have a specific boundary. Width sometimes is a little bit more flexible, but those 3 dimensions are really what kind of narrow down bearing selections. Now, if you're dealing with a housed unit, sometimes dimensions like how high the shaft center line is, attachment bolt location, size, and any height restrictions are also valid. So once you determine what your restrictions are, you can navigate our assortment easily. So we have tools online like Bearing Select, where if you have a specific range of diameters to deal with, you can sort through there. We also have our shaft simulation tool, which you can narrow down bearings based on those 3 dimensions as well. And similarly, our product tables are online. So we make it easy once you know those critical dimensions to sort through what designs can you actually use. Now, the next step is understanding how is the bearing going to perform. Okay, what bearings do, they support load. Now there's different types of load. There's radial load, thrust loads, or also axial loads, sometimes moment loads. So we need to pick the right bearing for that specific application. Some bearings are meant to do one thing, some bearings are meant to do multiple things in terms of load support. So we need to know what the application is going to require. Speeds, obviously the bearing is there to keep one component rotating, the other one stationary, but at what rate? So we need to know all the different speeds that are going to be part of the application. Temperature is also very important. That affects thermal expansion of the steels and also affects the performance of the lubricant. So we need to know all the full ranges that we're going to see. And what's actually commonly spoken about in terms of performance is fatigue life, or you also hear bearing rating life, or L10. So that's a way for us to really evaluate based on the selection, the loads, speeds applied, what type of life are we expecting. And certain equipment requires certain design of bearings. So it's important to know what, if you have a specific standard to follow. Similarly, industry standards for specific machinery will already dictate what design is supposed to be used. So a lot of this parameter is really required to really understand your selection. How is it going to perform? Now, there's also arrangements to consider. Many times bearings aren't just used as a single item. They come in a specific arrangement. So sometimes there are cases where you have more than one bearing, as you can see on the image there on the right. This is a pair of single oriented contacts mounted together, but not in the same orientation. Sometimes you have house assemblies that are used together, but for different functions. Here you have a both overhung centrifugal fan design, one bearing supporting one type of load, the other supporting another type of load. So it's important to know the number and what their purpose is. Now, orientation is also important. You have horizontal and vertical being very common, and it's important because they may not function the same way. The loads won't be the same when you switch orientations. The performance of lubricant is not also going to be the same. So it's important to know how that's supposed to be oriented. And there's other features to consider. Depending on your housing design, it may have certain restrictions on what bearings you can use. For example, here we have an electric motor, and one bearing position requires it to be the locating, basically supporting the thrust load, while the other one is non-locating, which is allowing the shaft to actually either expand or displace. So it's really important to know what the function of the bearing will be when you're using more than one bearing. Now, when you deal with mounted units or housed units, it's important to know what type of housing is the right one. As you can see on the right, there's different type of there's different type of housings. For example, pillow blocks, also known as plumber blocks. They come in split, solid. Sometimes the housings are flange. You can have a round flange, square flange. You have a take-up unit design. So knowing the right type of design is important. The material is also important. Not every material is going to work in the same application correctly. Cast iron being very common, but we also see housings that are made out of stainless steel. Some even ductile iron. So really understanding what is the right material for the application. And you have environmental factors to consider. Do you need corrosion protection? In some cases, some housings are made of stainless steel or composite. And also lubrication. Not every housing design can be used with oil. So knowing which housing is going with grease and oil is also important. Two other points is what we just talked about in the last slide is load carrying ability based on the housing design. What loads does it support? And is there any specific requirements of the support surface? These are things that are really important to know before you select the right housing. Shaft locking method, there's numerous ones out there, but it's important to know what your application calls for. For example, very common is when you're dealing with a housed unit, like a ball bearing housed unit, you'll see set screw locking on the shaft, which is typically adequate, but sometimes you have maybe high loads or vibrations that may shake that set screw loose. You may want to go with a concentric style of lock, which is on the left. It uses a sleeve to lock onto the shaft a little bit more concentrically than a single point on the set screw. When you're dealing with standalone bearings, you often see whether you have a straight bore mount directly on the shaft, a tapered mount on the shaft, or sometimes you even see the use of a tapered sleeve with a tapered bearing. All have advantages and disadvantages, but really your application should dictate which one is most ideal. A lot of the factors that go into it are, for example, when you're dealing with tapered mounts, is it can facilitate mounting and dismounting a little bit easier than going on a straight board. When we're dealing with seals and enclosures, some keys to note is seals and enclosures help prevent contamination from reaching the bearing and the lubricant. When we talk about seals and individual bearings, they're often integral with the bearing, as you can see on the left. Same thing with shields. Shields are metallic, while seals tend to be elastomers, but they tend to prevent contamination from coming into the bearing and sacrificing the surfaces and the grease. When you're dealing with housed units, for example, non-split housed units, a lot of the seals tend to be part of the housing or bearing assembly. When you're dealing with split, you typically have options where you can take a seal and change it based on the requirements. As you can see toward there, you have a labyrinth ring seal, and next to it is a floor lip contact split. So it really depends on the application, what it calls for. Now, when you're dealing with non-housed units and maybe dealing with specific machine design, you will probably see more of these external seals that are outside of the bearing itself. And so you would run into some of those on the OEM designs. When you select the bearing, you do need to consider the ease of assembly, disassembly. Okay, because at some point, this machine or the bearing or the mounted unit will have to be assembled and disassembled. So you don't want to make it impossible to do that. In addition, once it's placed in operation, at some point, there's going to be some inspection or maintenance required. So making that process easy to go into your decisions on what is the right bearing to select. Now, when you deal with housed units and assemblies, it can be important to keep track of everything because you're dealing with a lot of components. So, for one, variations can exist. So you need to know what are the internal design features required because those can vary. In addition, the component quantities is also very important to keep track of. Some things come in multiples and are required in multiples, in some cases like locating rings, which fix the ability of the shaft or assembly to move axially. Those have to be inserted, installed in the right quantities, or bearing will not perform as it's designed. As we mentioned, housings can come in different materials. In some cases, the bearing inserts themselves can come in materials. Keeping track of that is very important. And also design modifications, which is very common with split housings based on the applications. It could be condition monitoring, it could be seals, even materials modifications are made. It's important to keep track of what those are when going to just select or even replace an existing assembly. So we've covered most of the selection criteria. The last one we're going to tackle is lubrication, and it's a big one. So we're going to actually look at all the parameters that go into lubrication selection. Now, many of you've probably heard, but a lot of bearing failures, 36%, are related to poor lubrication. And in what ways? Well, for one, incorrect intervals and quantity can lead to over or under greasing. The improper selection can lead to poor performance of the lubricant and poor performance of the bearing. And also the environmental factors like contamination can reduce effectiveness of the lubrication and then also affect bearing performance. So you may hear this term used a lot, adequate lubrication, but what is it? What we mean is we want the right lubricant with the right amount, delivered with the right system, at the right time, to the right point of the bearing. When all of that is done properly, that's what adequate lubrication is. So how do we decide what is the right lubricant? There's a decision-making process in going to selecting some of the most common lubricants, which is either oil or grease. These are factors to consider. Do you already have a lubricant in use in your design? For example, in a gearbox, you may have gear oil there. Can it be used to lubricate the bearings? In certain cases, you may have a spec that calls out the use of a specific oil. For example, automotive standards call out automotive oils. So that's something you may have to work with already. In terms of the accessibility and maintainability of the machine, you may not be able to easily change the lubricant. So that's something, or even monitor. So that's something to consider when you're selecting oil or grease. Obviously, grease, once you place it in service, it's rare that you have to clean it out. You typically replenish it and keep what's there operation. However, oil does require a little bit more inspection and maintenance. So these are things that will have to be considered. In addition, if you have high temperatures, heat removal, oil will probably do better because you can circulate it and it can take away heat better from the bearing. In addition, you also may have contaminants in your environment. Grease may actually be an advantage because grease can act as a barrier to preventing contamination from reaching the contact surfaces. That goes along with sealing. So these are decisions that may skew you one way or the other when you're deciding, is it oil, is it grease, and then obviously what viscosity levels, what consistency, if you're doing grease, maybe there's a need for additives, there's a contamination. That's kind of the general process in selecting the right lubricant. So what is the right amount? Does that look like the right amount of grease? No. Does that look like the right amount of grease? No. What we're dealing with on the left is the excessive amount of grease, which is basically exploding through most of the crevices. And what it's going to lead to is a lot of frictional resistance and also a lot of probably heat. That's not an ideal case. And on the right, there's no sign of grease at all. So that's going to lead to metal-to-metal contact and wear. It's going to generate internal contaminants, and you're going to have very poor fuel performance. So where do we want to be? The right amount of grease is somewhere in between. Okay, so what is that? When you're dealing with open bearings, first of all, we'd like to fill the bearing with grease. Very commonly, standard is to fill the free volume 100% full of grease. Now, when you're dealing with sealed bearings or in bearings with enclosures, integral like the spherical bearing we saw previously, it's common to see anywhere between 25 and 35% of its free volume in the bearing filled. There's other applications that call for different percentages, and I would say I would leave that as application specific. In terms of the housing, there is grease required in the housing. Most of the applications, 20–40% should meet those needs because it do need grease to kind of replenish itself once it's moved out of the bearing. So as the bearing rotates, it picks up new grease in the housing, acts as a reservoir. In terms of areas where there's high contamination, the grease itself can act as a barrier, as mentioned. So if we fill that volume up to 70–80%, we can ensure that we can have a little bit better protection in contaminated environments because it's harder for that contaminant to penetrate through the grease. Now that's initial. What about replenishment? We'll talk about that. So we talked about grease, but what is the right amount of oil? So on the left, you'll see a housed spherical bearing unit with a little oil sump there. What is the right amount? Very commonly, when we're dealing with horizontal applications and a static bath, the guideline is we want the oil level to reach up to 1/2 of the height of the lowermost ball or roller. So too much oil will probably generate heat, probably generate a little bit frictional drag. Too low won't lubricate all the surfaces, and we might see some wear and probably higher running temps, depending on how much wear there is. So that's a very general guideline that when you're dealing with horizontal static baths, something to remember. But there's a lot of different oil applications out there. You have vertical circulating oil mist. I would lean to you to follow the OEM recommendations there because there's a lot of parameters to consider. So when is the right time, once we have our initial amount of lubricant, when is the right time to relubricate? Now that's something that's not easily accessible or something you would know without a calculation. And the best way to do this is using some kind of tool. And we have a tool. This is what you see in front of you. It's called dial set. So it's based on the bearing size, the bearing type, the application conditions such as temperature, orientation, and then the type of grease. At least this tool focuses on grease and maybe the lubricator if you're using an automatic lubricator. And so what it'll tell you is it'll calculate the amount in grams of grease to replenish at a certain interval or hours. Okay, this is specifically for grease, but this should also be done by the OEM. But if you need to reevaluate it, this is one way to do it. So how do we deliver, or where is the right lubrication point? So in most open bearings, initial fill is typically done through the side because that's the easiest way to access the free volume space in the bearing. Now, once you fill the initial fill on the bearing, there's also a replenishment after operation, and there's multiple ways this can be done. As you can see on the house units below, one has through the top, which goes to the top center of a lubrication groove and holes on a spherical bearing, which is going to relubricate symmetrically around the bearing. So that's one way. Now, if there's a bearing that doesn't have a relubrication groove, typically they're lubricated to the side. So the goal with that, though, is that we have to ensure the grease migrates entirely through the bearing. And we don't want it overpressuring one side and not getting through the bearing. So that's something to consider when you choose where to relubricate. And certain OEM designs have their own method. The key things to consider here is, first of all, the bearing design, does it allow lubrication through the center, through the side, or both? Orientation, obviously, if you have a vertical orientation, then you may have to relubricate from the top down because you will be fighting gravity if you do it the other way. Keeping track of purge ports. As you put more grease in, grease does have to come out, otherwise you overpressurize. And if you overpressurize, you may damage the seals in the assembly. it's always really important to know how that lubricant flows through that bearing and also the housing. So we have different methods of relubricating. Which one's the right one? Okay. Now, the answer to that question is any system that can deliver the right lubrication with the right amount to the right location in the bearing consistently is the right lubrication system. Now, in most cases, that may be more than one system. On the left, you have pretty much your most manual method, which is hand packing a bearing. However, when it comes to ensuring that you have, for example, the right amount of grams or a specific oil flow rate through each bearing consistently at a certain interval repeatedly, the manual hand packer method is not going to be superior to a centralized auto lubrication system. So really, obviously, any system that can be consistent is ideal. However, there's also a cost associated with going to an automated process. So really the customer, the end user, has to decide. The automatic systems tend to be more consistent in lubricating, but is it fully needed? So really that's an evaluation for the end user or the OEM, as long as each system can deliver the right amount to the right location consistently. So we've gone through all the 9 steps in bearing selection process. We've talked about lubrication. In summary, for those who don't do this on a regular basis, we've broken this process down into 9 key steps. They don't always have to be followed in sequence. You may not have to go through all of them, but at least you have an understanding of what is required. After you do some of those steps, you still have to go through an evaluation like understanding bearing performance, and that requires use of literature like our catalog and our website tools. Even after doing that, there's still a lot of information to navigate. So I always recommend, even after you've done all your due diligence, you can pick up the phone and talk to an application expert like myself and make sure you feel confident about your selection. So thank you for attending this presentation. Hopefully you've gained a little bit more knowledge than you had. And I'm willing to take any questions, but if there's no questions, thank you for attending and best of luck and enjoy the rest of the summer.
Wonderful. All right. Well, thank you so much. That was really good, and I have been looking forward to this one all conference. So thank you. That was awesome. And I just realized how little I know about about bearings. So, I think there are some a couple of questions here. So there's a question here on grease lubrication through automatic dispensers. Let me just show this up here on the screen. So do you believe grease lubrication has better results through automatic dispensers programmed to apply grease from period to period, or by a method of only lubricating by condition monitoring, for example, using vibration?
Yeah, thanks for that question, Greg. And that's a really interesting and relevant one. I was talking with a customer recently where they're trying to predict preemptive failure of a pump, and they're doing it through vibration monitoring. And it's a challenge because if you don't collect the right data at the right time, you really don't know what's going on inside the bearing housing where the lubrication is. So I actually recommend not only just more frequent monitoring, but also proper relubrication. So repeatable lubrication, as I presented earlier, that comes from systems, and automatic lubricators are systems. So that's a good insight, good suggestion, and I hope people kind of adopt that more. Hopefully that helps their assets run longer. A good question, great question.
Excellent. Good. Well, I think there are some other questions as well, but I think we've actually run out of time. So if it's all right, those of you that have any bearing questions in general, I think you've seen now we have an excellent expert on the subject. Please feel free to reach out directly to Gakuo, and But thank you so much for your presentation. It was really well done, very informative, and I really appreciate it.
Thanks for attending, everyone. And Greg, thanks again.
All right. See you at the next session. Thanks, everyone.